6. A particle p moves with constant acceleration, so we can use the constant acceleration formulae, of 2I minus 3j. At time t seconds, the velocity of p is v. When t equals 0, v equals 10I plus 4j. So that's actually our initial velocity u. Find the direction of motion of p when t equals 6, giving your answer as a bearing to the nearest degree. So I have acceleration, initial velocity, and time, and I'm trying to find the direction of motion. So the direction of motion will be governed by the velocity. So we've got v, u, a, and t. I can use v equals u plus a t. I prefer to write these as column vectors when I'm calculating. So the vector v is equal to u, which is 10I plus 4j, 10, 4, plus a, minus 2, 3, and t is 6. So now the vector v is 10 minus 12, which is negative 2 in the I direction, and 4 plus 18, which is 22 in the j direction. I've got to find the direction, which will I'll do by setting up a triangle to just show that. If I draw this down here on some axes, and I'm going to mark this as its bearing, I'm going to mark this as the north line. So imagine I go 2 back to there, and then I go up 22 to there. So I've got to calculate this angle here. And I'm going to do that by using tan. So arctan of opposite 22 over, and I'll use a positive value here, will give me 84.8. I can use 85 here, but I need the bearing, so that's from north going clockwise, so I need to add 270 to that. 85 plus 270, and that equals 355 degrees as a bearing. For part B, find the value of t when p is moving northeast. So imagine again, your compass northeast is perfectly diagonal in this direction, gradient of 1. So that means the I direction will be equal to the j direction. Now you can just find those and make them equal to each other, or I'll do it this way, that the vector, the velocity will be equal to, so I'm using v equals u plus at again. It will be a multiple, a scalar multiple of the vector 1, 1. So v equals u, which is 10, 4, plus a, which is minus 2, 3, multiplied by t. That gives me that in the I direction, k equals 10 minus 2t. In the j direction, k equals 4 plus 3t. And as they are equal to each other, 10 minus 2t equals 4 plus 3t. And I can calculate t, which equals 6 over 5, or 1.2. Marks wise on this question. There's a method mark for clear use of v equals u plus at. There's an accuracy mark for finding the vector v. There's a method mark for using tan with the positive value, and an accuracy mark for finding 85, and then a further accuracy mark for adding that to find the bearing. For part B, there's a method mark for either equating, finding the I and j components, 1, or setting up v equals u plus at, and then a method for an accuracy mark for finding those correctly, a dependent method mark for setting them equal to each other dependent on the fact that you've done this working here, and an accuracy mark for 1.2.